Hello guys, welcome back to another lecture in this course. In this video, we shall be looking into coordinate geometry or linear programming. So in linear programming, we shall be looking into a straight line, equation of a straight line. For example, we are given a Cartesian plane where we are having the y-axis and the x-axis. And we are having a straight line passing through the x and y-axis, the y and the x-axis on the xy plane. So this equation or this straight line is known as y equals to mx plus c, where c here represents the y-intercept, where the graph cuts across the y-axis at this point. And m here represents the gradient and y represents the function of the straight line. So in coordinate geometry or linear programming, what we need first, we need to have coordinates. To have a clear overview on linear programming, you should have coordinates, assuming the coordinates are in an array of 1, 2, and also we are having a pair of coordinates 3 and 4. These are the pair of coordinates that we are having. Once we have coordinates, we can be able now to find the gradient. Okay, so the coordinates give us an advantage to be able to find the gradient, and the gradient is denoted by m, and where m is equals to y2 minus y1 all over x2 minus x1. So by using these coordinates that we are having, we'll be able to find the gradient by saying m equals to, as this will be our x1, this will be our y1, and also this will be our x2, this will be our y2. Now let us find the gradient, where 4 minus 2 over x2, which is 3 minus 1, which is nothing but 2 over 2, and give us a gradient of 1. So now that we have our gradient, if you are having our gradient, it will be now simple to move to our next step. So we have coordinates, we are having our gradient. We need now to find the equation of a straight line, where y is equal to mx plus c. And where y, in machine learning, we are saying, especially when we are doing linear regression, we are saying y is our dependent variable. Y is our dependent variable, because y is depending with mx plus c. And also here, x is our independent variable. Independent variable. So, for example, you are testing the mathematics score. For example, you are testing math score. And when you are checking, you are trying to predict the result of math score. You are predicting the results depending if the student is able to read, and also is the student able to write. So the math score here, math score is a dependent variable. It is depending with the reading skill and the writing skill. So this will be y, this will be your variables, which are x, which are independent. Reading does not depend with writing. So these variables are independent. So we are saying y is equal to mx plus c. It is very useful and important in linear regression. So it is very important for you to understand the concept behind the linear programming. So now we are saying we are having y and x, and also we are having c, where c, y-intercept. And y-intercept is where the graph cuts across the y-axis. To find the linear programming line, we should still use our formula. m is equals to y2 minus y1 all over x2 minus x. But in this case now, and now we have to choose one pair of the coordinates. So we are going to use 1 and 2. So we are saying y minus 1 over x minus 2. Then we cross multiply both sides by x minus 2 times 1 is equals to y minus 1 here. So since we multiply both sides by x minus 2, it means we cancel this and this. And this gives us nothing but x minus 2 equals to y minus 1. Then when we collect like terms, it will end up being y is equals to x minus 2 plus 1. Now, which gives us a final answer of y is equals to x minus 1. So this is our equation of a straight line. Equation of our straight line. And this equation of a straight line is also known as our linear programming line, which is in the form of y equals to mx plus c, where our gradient is still 1. The y-intercept here is represented by c, which is minus 1. So if we are representing this information on a graph, if you are to represent the given information on a graph, it means we are drawing x and y called x-plane, x and y plane, where this is our y-axis and this is our x-axis. And the graph is cutting the y-axis at negative 1. And it is also cutting the y-axis, the x-axis, if we let y equals to 0, then it means that 0 is equals to x minus 1. Then x is equals to 1. So it is also cutting the x-axis at 1. Therefore, our linear line here of this equation, y equals to x minus 1, is cutting across the x-axis at 1 and the y-axis at minus 1. So this line here depicts a linear programming line or linear graph. This is a linear graph. So in machine learning, we'll be using this often. In most cases, you are having a graph like this. This is our y-axis, this is our x-axis, and you are having a line passing through at this point. So what is happening? Let us say y is equals to mx plus c, or y is equals to f of x, which is equals to mx plus c. This is a linear function. All these are linear functions. So whenever we are having a data, and our data, let us assume these are grouped data, and this data is closer to our linear function, this linear function. It means this data is related. And also when the linear function is going diagonally this way, it means that there is a positive relationship. But there is a negative linear relation when our linear function x here, when our linear function is going on this direction. Let us assume this is the data. This is f of x is equals to mx plus c. If the graph is like this, it means there is a negative correlation of the data. The data is not related well. So I think this is all for this lesson. Thank you for watching. See you on the next lesson. Bye-bye.